Hi guys, welcome to Unacademy KCET YouTube live session. Myself Sharif. In this particular video, we will discuss the PYQs of matrices and determinants part 1. And before I start guys, please do subscribe our channel, enable the bell icon. And if you're already subscribed, do share this video and please go through the description link below that description table below that link. Right, hi Sapna, hi Gaurav. Let us start guys. Right, question number 1. If A is a matrix of order 3 by if A is a matrix of order 3 by 4, A is a matrix of order 3 by 4 and B is a matrix such that A dash B and B A dash both are defined. If A is a matrix of order 3 by 4, A dash is a matrix of order 4 by 3, right? Right, now A dash B is defined. If A is a matrix of order M by P and B is a matrix of order P by N, the matrix AB exists only when the number of columns of A is same as matrix AB is defined only when number of columns of A is same as number of rows of B. This fellow is defined only if it is m by n. That is, number of columns of A is same as number of rows of B. Right, now if I use this logic, it is given in the question that A dash B and B A dash both are defined. Okay, now according to the question, B dash is a matrix of order 4 by 3. Sorry, A dash is a matrix of order 4 by 3. Even this is the order of 4 by 3. Right, if this is 3, this should also be 3. If this is 4, this is also 4. Alright, number of columns of first is same as number of rows of second. Here also same. Right, so this means that number of rows of B, this is rows into column, right? Rows by column, rows are 3, right? Columns are 4. So B is a matrix of order 3 by 4. Answer is option B. Right, let's move to the next question. Question number 2. See, this is of the form A into adjoint of A. This is of the form A into adjoint of A is equal to determinant A into I. Right, and from this, determinant of A is equal to 10. Determinant of A is 10. Determinant of adjoint A is equal to determinant A power n minus 1. Determinant of adjoint A is determinant A power n minus 1. N stands for order of the matrix. Okay, n is equal to 3. It's already given that it's a matrix of order 3. So 10 to the power of 3 minus 1, which is 10 square. Right, 10 square is equal to 100. Answer is option C. Let's move to the next question. Question number 3. If A and B are symmetric matrices of same order, symmetric means A transpose should be equal to A, right? And B transpose is equal to B. So A and B are symmetric matrices of same order. A transpose is A, B transpose is B. So A and B are symmetric matrices of same order. Then what is AB minus BA? See, if a matrix which is equal to its own transpose, A transpose is equal to A, means A is symmetric. This is symmetric. And if A transpose is equal to minus A, then this is A, then A is skew symmetric. This is skew symmetric. So if it is equal to its own transpose, symmetric. If it is equal to negative of its own transpose, then it is skew symmetric. I'll find out AB minus BA and then take the transpose of this. A minus B transpose, I can write this as AB transpose minus BA transpose, right? Okay, further AB transpose is equal to B transpose into A transpose, and BA transpose is equal to A transpose into B transpose. This is A transpose into B transpose. B transpose is B, right? A transpose is A. That's already given in the question. A transpose is A, B transpose is B. If I take minus common, it is AB minus BA. So I'm getting negative of its own transpose, that is AB minus BA transpose. AB minus BA whole transpose is equal to minus of negative of its own transpose. So left side I have AB minus BA, okay, whole transpose. AB minus BA whole transpose is equal to negative of its own transpose, so it should be equal to skew symmetric. If it is equal to its own transpose, then it is symmetric. Equal to negative of its own transpose, then it is skew symmetric. Actually, you can remember these results, guys. These two are standard results, that if A and B are symmetric matrices of same order, if A and B are symmetric matrices of same order, AB plus BA is symmetric. AB plus BA is symmetric, and AB minus BA is skew symmetric. This is skew symmetric. So if A and B are symmetric matrices of same order, AB plus BA is symmetric, AB minus BA is skew symmetric. Right, let's move to the next question. Question number 4. Yeah, you can solve, no problem, but it's a standard result, Gaurav. If A and B are symmetric matrices of same order, AB plus BA will be symmetric, AB minus BA will be skew symmetric. Okay, question number 4. I'm supposed to find the symmetric part of the matrix. Okay, anyways, you have done this in boards, that any matrix can be written as sum of a symmetric plus skew symmetric. A plus A dash by 2 plus this is A minus A dash by 2. This A plus A dash by 2 is symmetric. A plus A dash by 2 is symmetric, and A minus A dash by 2 is a skew symmetric. Skew symmetric, so I am supposed to find the symmetric part. Symmetric part will be equal to, symmetric part of the matrix is A plus A dash by 2. Okay, so this is equal to half of into a matrix. This is A, right? So if I take suppose A transpose is equal to 1 2 4. First row becomes first column, then second row becomes the second column, third row becomes third column. A plus A dash, if I add this, you will get this as 2 8 6. Okay, and then you get 8 16 0, and then you get this as 6 0 and 14. If I divide by 2, you will get this as 1 4 3 4 8 0 3 0 7 3 0 7. This is 3. You will get the last option D, right? You get last option D only. All right, let's move to the next question. Question number 5. See, I should find out the relation between delta and delta I, right? See, delta I is equal to, if I take the transpose of that, because determinant A is same as determinant A transpose, right? Hi Shubham. Determinant A is same as determinant A transpose. First row becomes first column, and second row becomes the second column, and the third row becomes third column, zy, zx, and xy. Okay, now delta I is equal to, first row you multiply by x and divide by x. This becomes ax, x square, and xyz. Second row, if I multiply and divide by y, so this is equal to by, this is y square and xyz. Third row, if I multiply and divide by z, you get cz as z square, and then you get xyz. Okay. Now I'm going to take xyz out from the last column. So this is delta I is equal to 1 by xyz. From the last column, I'm going to take xyz common. This becomes determinant of ax, by, and cz. This is x square, y square, and z square. And then you get 1, 1, 1. I'm going to cancel this. Delta I is same as delta, because this is same as delta, right? Delta I is equal to delta. Answer is option C. Is it clear, guys? Let's move to the next question. Okay, I'm supposed to find what is inverse of the matrix. Okay, question number 6. I'm supposed to find inverse of the matrix. Shubham, it's very clear. My video is very clear. I've logged in with another device. I can see it's very clear, dude. Just check your internet connection once. No blur. It's very clear. You can check your internet, or check your camera or something. See, it's a standard NCRT result that if you have NCRT result that if you have A is equal to matrix A 0 0 0 B 0 and 0 0 C. Suppose you get a diagonal matrix, then A inverse is equal to principal diagonal elements is 1 by A. This is 0 0 0 1 by B 0 and 0 0 1 by C. This is A inverse. So inverse of a matrix, principal diagonal elements are 2 3 4, right? So you get 1 by 2 1 by 3 1 by 4. Answer is option D only. Okay, question number 7. If ABC are in AP, even this is NCRT MCQ only. If ABC are in AP, 3 numbers are in AP, you should write 2B is equal to A plus C, right? That is A plus C minus 2B is equal to 0. So this is equal to determinant of change R1 to R1 plus R3 minus 2 times R2. R1 plus R3 is 2x plus 8 minus 2 times R2 is 2 times x plus 4. Open the bracket, this will be 0. This is R1 plus R3. R1 plus R3 will be equal to 2x plus 10 minus 2 times R2 is x plus 5. You open the bracket, this is 0. Again R1 plus R3, 2x plus A plus C minus 2 times R2 is 2 times x plus B. Oh, you can't see, my camera is blocking. Okay, I'll do it here, guys. Okay, I'll do here. So R1 plus R3, right? R1 plus R3, 2x plus 8 minus 2 times R2, 2 times x plus 4. You open the bracket, you get 0. Again 2x plus 8, 2x plus 10 minus 2 times R2 is 2 times x plus 5. Open the bracket, it is 0. Right, again R1 plus R3, 2x plus A plus C minus 2 times R2 is x plus B. If you open the bracket, you get A plus C minus 2B, which is equal to 0. This is 0. Second row will be equal to x plus 4, x plus 5, x plus B. The last row is x plus 6, x plus 7, and then x plus C. All 0 property, it will be 0. Answer is option E. Is that clear, guys? Let's move to the next question. Okay, question number 8. A is equal to matrix given. Determinant A cube is 27, right? The determinant of A cube is 27 means this is same as determinant A whole cube is 27, right? 3 cube, right? So determinant A is equal to 27 or determinant A is equal to 3. Determinant A cube is equal to 27, determinant A is equal to 3. So determinant A is equal to 3. If I have suppose determinant A power n, this is same as determinant A whole power n. Okay, now determinant A value will be equal to alpha square minus 4. This is alpha square minus 4 is equal to 3. Alpha square is equal to 7. Alpha is equal to plus minus root of 7. That is answer option C. Is that clear, guys? Okay, question number 9. This is determinant of first column is log x, second column is log 2x. Log 2x can be written as log 2 plus log x. Log 3x can be written as log 3 plus log x. This is log 3 plus log x. This is log y. Log 2y can be written as log 2 plus log y. Log 3y can be written as log 3 plus log y. Log z, last column is log z. Log 2z can be written as log 2 plus log z. Log 3z can be written as log 3 plus log z. Right, now determinant of, I'm going to change R2 to R2 minus R1. First row will be equal to log x. This is log y. This is log z. Okay, R2 minus R1 is log 2. Even this is log 2. This is log 2. R3 minus R1 will be equal to log 3. This is log 3. This is log 3. Right, in the second row, I'm going to take log 2 out. In the last row, I'm going to take log 3 out. Determinant of first row is log x. This is log y and log z. Second row is 1, 1, 1. Last row is 1, 1, 1. Two rows are identical. Answer is 0. Answer is option B. Is it clear, guys? Let's move to the next question. Okay, A plus A transpose. A plus A transpose is equal to I. Matrix A is equal to cos 2 theta minus sin 2 theta plus sin 2 theta and cos 2 theta. Okay, plus A transpose, first row becomes first column. First row becomes first column, second row becomes the second column. Sin 2 theta into cos 2 theta. And I can be written as 1, 0, 0, 1. Right, now if I add these two, this is 2 cos 2 theta. This is 0, this is 0, and then 2 cos 2 cos 2 theta is equal to 1, 0, 0, 1. Now if I equate them, 2 cos 2 theta is equal to 1. Cos 2 theta is equal to 1 by 2. Okay, now cos 2 theta is equal to 1 by 2. 1 by 2 can be written as cos pi by 3 because cos 60 is half. 2 theta is equal to pi by 3. Theta is equal to pi by 6. Right, answer is option D. Question number 11. The number of all possible matrices. Just a sec. Yeah, number of all possible matrices for order 3 by 3. The number of all possible matrices of order 3 by 3 with each entry 0 or 1. Obviously 3 by 3 matrix will have 3 rows and 3 columns, right? Now each element should be filled with either 0 or 1. The first place can be filled, so three rows and 3 columns will have 9 elements. Each entry should be either 0 or 1. First place can be filled in 2 ways, second place can be filled in 2 ways, third place can be filled in 2 ways, like this and so on up to 2. This is 9 times. Okay, so this is 9 times. 2 multiplied 9 times, you will get 2 per 9, which is 512. Answer is option D. Okay, question number 12. If A and B are two matrices, two square matrices, such that AB is equal to B and BA is equal to A, what should be the value of A square plus what should be the value of A square plus AB? What should be the value of A square plus B square? The A square plus B square. A square can be written as A into A, right? B square can be written as B into B. This A is same as BA, right? Again, A is same as BA. Plus this B is same as AB. Again, B is same as AB. Now this is equal to B times this is AB into A plus A into BA into B. Right, now this B I'll keep as it is. AB is same as B, right? According to the question. Plus A into BA is same as A. So this is A will be there. And then B is same as A into B. Again B I'll keep as it is. B into A is equal to A. And then A into B is equal to B. Again B into A is equal to A. And A into B is equal to B. A square plus B square is A plus B. Answer is option D. Right, let's move to the next question. If A is a matrix of order 3 by 3, then what is determinant of Ka? The determinant of Ka, if you take K outside the determinant, this is K power n into determinant A. N stands for order of the matrix, so it's given A is a matrix of order 3 by 3, n equal to 3. This is K cube into determinant A. That is answer is option D. Okay, question number 14. Determinant of A, B and B transpose can be written as determinant A into determinant B into determinant B transpose. This is determinant A into determinant B. Determinant B transpose is same as determinant B. Now determinant of A is equal to, you will get 2 minus 12, which is minus 10. Okay, and then determinant of B will be equal to 4 plus 1, which is equal to 5. So this is 5, this is 5. You get minus 250. Answer is option A. Right, let's move to the next question. Question number 15. So this is a very simple question. 3 into 1 is 3, x into x square. If I expand the determinant, this is 3 minus 8. It will cancel minus as well. X square is equal to 8. X square is equal to 8 means x is equal to plus minus root 8. x is equal to plus minus root 8 can be written as 2 root 2. That is last option D. Right, question number 16. I'm supposed to find out what is A minus B. It's a standard NCERT exemplar question which was asked in KCET. If I subtract A minus B, 1 by pi is a constant. The sine inverse of pi x, minus and minus is plus, this is cos inverse of pi x. Okay, and then this will be 0, this is also 0, and then cot inverse of pi x plus tan inverse of pi x. Now if I 1 upon pi, I'll keep as it is. Sin inverse of x plus cos inverse of x is pi by 2, right? Sin inverse of x plus cos inverse of x is equal to pi by 2. This is pi by 2, 0, 0, pi by 2. Okay, now I'm going to take 1 by pi and take pi by 2 common. You will get 1, 0, 0, 1. The pi and pi cancels. This is half of I. 1, 0, 0, 1 is an identity matrix. The 1, 0, 0, 1, half of I. Answer is option B. Is it clear, guys? Twice this question is asked in KCET. Question number 17. If A is a square matrix of order 3, and I told you, right, determinant of adjoint A, we did this before as well. Determinant of adjoint A is determinant A per n minus 1. N stands for order of the matrix. If A is a matrix of order 3, so n equal to 3. Right, determinant A is 3, so this is 3 to the power of 3 minus 1. That is equal to 3 square, which is equal to 9. Okay, answer is option B. Let's move to the next question. Question number 18. I am supposed to find the values of x and y. If I multiply the first row, first column, this is x plus y. Second row, first column is minus x plus y is equal to 2, 4. Now, if I equate, you get x plus y is equal to 2, and x minus x plus y minus x plus y is equal to 4. This will cancel. You get 2y is equal to 8. That is y is equal to 2. Y equal to 2, if I substitute in equation 1, x will also be 2, right? That is x plus 2 is equal to 2. Sorry, x plus 2 is equal to 2 means first row, first column x plus y, y is equal to 4, right? Y is equal to 4. Now you're supposed to find the value, Sagar, supposed to find the value. X plus 4 is equal to 2, x is equal to 2y is equal to 6, yeah, right. 2y is equal to 6, y is equal to 3. If y is equal to 3, if I substitute, you get x plus 3 is equal to 2, x is equal to minus 1. X is minus 1, y is 3, last option. Is that okay? Yeah, 2 plus 4, 6, I took 8 actually. So y is 3, x is minus 1. And let's move to the next question. See, this was asked in KCET 2019 paper. Good question, just follow carefully. First, I'll find out a square. A square is a into a. 2 minus 2 minus 2 plus 2. Again, this is 2 minus 2 minus 2 plus 2. This was asked in 2019 paper. If you multiply first row, first column, you get 4 plus 4 is 8. You get minus 8 plus 8. So this is equal to 4 into, you will get 2 minus 2 minus 2 plus 2. This is 2 square a. 2 square can be written as 2 to the power of 2 into 2 minus 1 into a. This is a square. Now a cube can be written as a square into a. So this is 8 minus 8 minus 8 and plus 8. And this is equal to 2 minus 2 minus 2 and plus 2. Is equal to 16 plus 16 is 32 minus 32 minus 32 and plus 32. Take 2 outside, 16 outside. You will get 2 minus 2 minus 2 and plus 2. 16 is 2 power 4 into a. 2 to the power of 2 into 3 minus 1 into a. Alright, so I got a square, I got a cube. Similarly, a to the power of 4 will be a to the power of 2 into 4 minus 1 into a. And a to the power of n, 2 to a to the power of n is equal to 2 to the power of n. 2 to the power of n minus 1 into a. A power n is equal to 2 power n into a. So if I compare this with a to the power of n is 2 power k into a, the value of k will be equal to 2 into n minus 1. That's the last option, isn't it, guys? This was asked in KCET 2019 paper. Let's move to the next question. See, actually degree should come here. Right, if I multiply principal minus secondary, so this is cos 15 into cos 75 minus sin 15 into sin 75. But this fellow is of the form cos A into cos B minus sin A into sin B, which is equal to cos of A plus B. Okay, so this is cos of A plus B means cos of 15 plus 75, which is equal to cos 90. Okay, and cos 90 will be equal to 0. Answer is option B. Alright, let's move to the next question. A is equal to minus A transpose, right? If A is equal to minus A transpose means negative of its own transpose means is A should be skew symmetric only, right? Alright, otherwise if I equate this, A transpose is 1 4 x 1 4 and then minus 1 0 7 minus 4 minus 7 and 0. This is A. This is A transpose, sorry. Minus A will be equal to minus 1 minus x minus 1 minus 4 1 0 minus 7 4 7 0. Now if I equate x is equal to minus x, 2x should be equal to 0, x is equal to 0. Answer is option A. Or directly you equate x is a negative of its own transpose skew symmetric. In skew symmetric, all the principles should be 0. Directly x is equal to 0. Question number 22. See, whenever the arrangement of numbers are in AP in a 3 by 3 determinant, value of a determinant is always 0. You want to still prove it? 1990, 1991, 1992, 1992. If I R2 minus R1, if I subtract, this is 111 and R3 minus R1 will be equal to 2, or you subtract R3 minus R2, directly you will get. Change R3 to R3 minus R2, you will get 111. Two rows are identical, answer is 0. Right, let's move to the next question. Question number 23. See, 3A plus 4B transpose is there, right? I'm supposed to find B, right? Okay, let's call equation 1. You take transpose there. If I take transpose for this becomes 3A dash plus 4 B dash of dash is B. First row becomes the first column and second row becomes the second column. Okay, and then this is 3B, sorry, 2B plus 3A dash. 2B minus 3A dash. I can write this as 2A dash minus 3a dash plus 2b is equal to matrix minus 1, 18, 4, 0, minus 5, minus 7. Right? If I add these two now, this fellow will cancel. 4b plus 2b is equal to 6b is equal to matrix. Add this, you get 8. Sorry, 6. This is 18. And then minus 6 plus 6 plus 12. Then plus 27, right? 24. To divide, now matrix B is equal to 1, 3, minus 1 plus 1, 2, 4. Answer is option C. Yes, answer option C only. Right, let's move to the next question. The inverse of the matrices. The actually A inverse formula. What's A inverse now? A inverse is equal to 1 by determinant A into adjoint of A, right? Determinant A is equal to delete first row, first column. Minus 5, delete first row, second column. And then first row, last column is 0. Anyways, you get 1. If you want to find the adjoint, right? You take the center element 1. Below 1 I have 0. Left out in this column is 5. Repeat the first element. Do the same thing for the third column. It will be equal to 1, 3, 0, 1. Do the same thing for first column. Center element is 0. Below that minus 1. Left out in this column is 2. Repeat the first. Repeat the entire first column. 1, 0, 5, 1. So this minus this adjoint will be equal to 3. Again, this minus this is minus 1. If you go row wise, enter column wise. If you go column wise, enter row wise. This minus of minus is plus 1. This minus this is minus 15. Again, this minus this is 6. Principal minus secondary is minus 5. Again, this is 0. This is 5 minus 0. 0 minus 2 is minus 2. Plus 2. Answer should be D only. Right? We'll do one more question. Question number 25. The value of a third order determinant is 16. So determinant A is equal to 16. Then the value of a determinant formed by the replacing each of its elements by cofactors. That is that the adjoint. Transpose of a matrix formed by the cofactors is called adjoint. Determinant of adjoint A is determinant A power n minus 1. It's mentioned here, it's a third order determinant, n is equal to 3. So 16 square is 256. Answer is option D. Okay, question number 26. What is A into A transpose? A into A dash. A into A dash is equal to matrix is cos alpha, sin alpha, minus sin alpha into cos alpha. Into A dash is the first row becomes first column. Second row becomes the second column. Now this is cos square alpha, okay, plus sin square alpha. Then minus sin alpha cos alpha plus sin alpha cos alpha. And then minus sin alpha to cos alpha plus cos alpha into sin alpha. And then this is sin square alpha plus cos square alpha. It will cancel. You will get 1, 0, 0, 1, which is equal to identity. Answer is option D. Right? So I'll stop here, guys. We will continue this session with in my next session at 5 o'clock or 5:30. I'll log in and we'll start with part 2 of this paper. Okay, until then, take care, guys. And if you haven't subscribed, do subscribe the channel. Please like and share this video, guys.